Hello everyone, welcome back. My name is Greeshma, working as a technical marketing engineer in Cisco. This is the third and final part of our Cisco FTDv clustering with Autoscale in AWS series. In this video, we'll dive into the operational aspects of the setup we built earlier. If you have followed along, in part one, we covered the concepts, and in part two, where we deployed everything hands-on in AWS. And if you haven't watched part one and part two yet, I would highly recommend checking those out first to get the full context. We covered all the concepts and the complete hands-on deployment there. I'll provide those links in the description below. In this video, we'll take it a step further and look at how the solution behaves in real-world scenarios. Things like how the traffic flows or target failover works or scaling events and monitoring, and walk you through the AWS console and firewall management center and show you the target failover in action, right? So as I mentioned, we deployed everything needed for this solution in the previous video. So here we'll look into the operational aspects of this solution. This video is helpful for you if you are working on the cloud security or the network operations, whether you are a cloud or security engineer or a firewall administrator, or someone who just wants to understand how Cisco FTDv cluster with Autoscale actually behaves in a real AWS environment, right? And if you are into designing, deploying, or managing secure cloud architectures, this walkthrough will give you a clear picture of what happens behind the scenes once your setup is live. So let's get started and see Cisco FTDv clustering with Autoscale in action. Okay, so this is the architecture. This security VPC is what we deployed in the AWS in the previous video, where we deployed the security VPC, subnets, firewall cluster, gateway load balancer, this gateway load balancer endpoint, route tables, and all the required resources using the CloudFormation templates. I'm not showing all those components here in this architecture, but we'll explore all those in the video on the AWS console. But if you look at the VPC resource map in the AWS console, you will notice multiple components such as subnets, route tables, and network connections. While the resource map doesn't display every element of the deployment, it provides a good visual overview, and you can explore all the deployed resources directly in the AWS console for more details. Let's actually go to the AWS console and take a look at the resources that we deployed. Okay, now we are in the AWS console. If you followed the previous videos, you will remember that we launched two CloudFormation stacks. The first one is demo infra, which you can see here. Deployed all the underlying network resources. If you open the resource tab here, you can view everything that was created as a part of this stack, including the VPCs, VPC endpoint, multiple subnet across different availability zones, route tables, security groups, internet gateway, elastic IPs, and access control lists, etc., right? So similarly, the second stack, demo cluster, deployed the firewall cluster along with the gateway load balancer endpoint, target groups, auto scaling group, dynamic scaling policies, CloudWatch log groups, Lambda functions, IAM roles, and more, right? So yeah, these are the two stacks that we deployed. And if we move further under EC2 instances, these are the FTDs that we deployed. All these FTDs are part of the cluster and span across different availability zones in the region. We can see all the details of the FTD from here and the various network interfaces that are attached to the FTD, the private IPs, public IP addresses that are attached to these interfaces, and the key pairs attached to the VM or the security groups, route tables attached, etc., etc. You can see all the information from this page, right? Okay, moving further, let's look at the autoscaling group. So this is the autoscale group that we deployed. In AWS, autoscale group is responsible for automatically managing the number of instances based on the demand. It ensures that the desired number of firewall instances are always running in the network. If one instance fails or becomes unhealthy, the autoscaling group automatically replaces it with a new one. Right? It can also scale out and scale in dynamically based on predefined scaling policies or the CloudWatch metrics. So in our setup here, the autoscale group helps maintain high availability and elasticity of for the FTDv cluster by launching or terminating the instances as and when needed. And here you can edit this and can set the minimum and maximum number of instances and the desired capacity. The FTDs will scale up or scale down dynamically based on the memory, CPU, and also based on the health of the FTDs, right? If you see here, now we have minimum instances as 3. For example, if we increase it to 4, Autoscale group will trigger the deployment of new instance. And as you see here, the new FTDv is getting deployed now, right? So it's in the initializing state. Once the deployment of new FTDv is complete and it is up and running, it also onboards that FTD to the CDFMC and it will become part of the cluster, right? Okay, so I don't want to now initialize the new FTD and onboard it to the new FMC. So let me change it back to 3. Okay. Okay, let's look at the gateway load balancer. Um, this component plays a key role in our setup. It sits in front of the firewall cluster and intelligently distributes the traffic across all the available FTDv instances, right? The gateway load balancer uses the Geneve protocol to encapsulate the traffic between the load balancer between itself and the firewalls, allowing traffic to pass transparently for inspection. Now, to manage these firewalls behind the gateway load balancer, we use something called as target group, right? So this is the target group that we deployed, and this target group is attached to this gateway load balancer. Here, each FTDv instance in our cluster is registered as a target within this group. Gateway load balancer relies on this target group to perform the health checks and to ensure that traffic is only sent to healthy and active firewall instances. And if you notice here in attributes, the target failover option is enabled. What it means is if one of the firewalls becomes unhealthy or goes down, the gateway load balancer automatically detects that through these health checks and immediately stops sending traffic to that particular instance. The traffic is then rerouted to one of the remaining healthy FTDv instances, ensuring that continuous inspection and high availability. And if you move forward and look into the CloudWatch logs, in our setup, CloudWatch also plays a very important role in monitoring and automation. All the firewall instances, autoscaling activities, and Lambda functions send the logs and the metrics to the CloudWatch. This helps us track things like instance launches or the termination, scaling events, and health check status in real time. For example, whenever the autoscale group scales out or scales in, or when the gateway load balancer performs the target health check, we can see those events captured here in the CloudWatch. These logs make it much easier to troubleshoot, monitor cluster behavior, and verify that the automation is working as expected. So we explored most of the components that were deployed as a part of the cluster. The stacks that we launched doesn't just deploy all these AWS resources and the firewall cluster, but also onboards that firewall cluster to the firewall management center. So when you use these templates as an end user or as a customer, you don't need to do much manually. So this is a walkthrough of the AWS console where we explored most of the components. Let's move over to the firewall management center. This is the FMC that we are using. If you remember, we provide the details of this FMC while launching the stack. From FMC, let's take a look at how these firewalls appear once they are onboarded and explore the cluster configuration and walk through some of the key monitoring and management options available within the FMC. Here, if you see, the templates that we used also onboarded the cluster to this FMC. This cluster currently has 3 firewalls. One of them is a control node, and the other 2 are the data nodes. Control node is basically the brain of the cluster. It manages configuration sync between all the nodes. See here, the interfaces are configured like we have management interface, a data interface, and 2 VNI interfaces, one for the Geneve and one for the CCL link, cluster control link. All the nodes in the cluster share the same configuration, right? Control node will overwrite all the configurations on the data nodes when they join the cluster. So you only need to perform initial configurations on the control node before you form the cluster. Control node also monitors the health of all the nodes and decides how new traffic connections are distributed across the cluster members. And if at all the control node goes down, another data node automatically takes over, ensuring that the cluster continues to operate smoothly. So while all the nodes handle traffic, control node is the one which is responsible for coordination and the overall cluster management. And there will be a cluster control link that's between all the nodes in the cluster. This is a dedicated communication channel between the nodes, right? It's used for exchanging the critical cluster information like the health status or the connection state updates and the control messages, right? Control link plays a key role in keeping all the nodes in sync. For example, when a new connection is established, ownership details are shared over this link, so every node knows exactly which peer owns that particular connection. Cluster control link, or CCL in short, is what keeps the entire cluster operating as a single and a coordinated system. From here, we can click on these three dots and we can click on this cluster live status. So as you can see, we have three nodes. All the nodes are in sync, and we can expand one of these nodes and can see the summary here, which will show all the summary of the node and history. So it will show all the history of that particular node. And here, if you see the CCL ping, so basically CCL ping tests network connectivity between all the nodes in the cluster using this dedicated CCL link. It sends a ping from this local node to every other node in the cluster, verifying the reachability and helping to identify issues with the cluster control's communication path. This is crucial because the cluster control link carries all the control and data traffic. So any disruption can cause a node to be removed from the cluster, right? So this CCL ping tests the connectivity between all these nodes, right? And as we see here, all the pings are successful, which means the control links are functioning fine, right? So you can similarly verify the same for all the other nodes too on the cluster. And here you can generate the troubleshooting files for different nodes in the cluster. And once the files are generated, you can download it from the tasks. If you see, we downloaded the troubleshooting file that we generated. So it will be in your local machine. You can take a look at that file, which will help you in the troubleshooting. And we can also uninstall the cluster from this firewall management center with using this option. So let's click on the health monitor and it will take us to the health monitoring page where we can see all the details of the cluster. This page will help the users a lot while troubleshooting. This is the control node and these are the data nodes. So we can hover over these nodes to see the status of the node or any alerts. You can see the cluster overall performance here, like the CPU usage, memory, input and output rate, active connections that we have, NAT translations, etc., etc. And we can change the time duration here on the top right corner. We can either set the sliding time range or the fixed time range and can see the last 5 minutes or 30 minutes information on the dashboard, right? Here, if you come to the load distribution tab, we can see the traffic distribution across various nodes in the cluster, like the number of connections per second or the packets per second, and can see the performance metrics like CPU, memory, connections, NAT translations, data throughput on each node, right? And under the CCL tab, we can see the CCL input rate, output rate. You can either see the graph for all the members at the same time or can see the individual node graph. And here we can see the performance dashboard. We can add a new dashboards here based on the use case or the requirement of the user. Based on here, you can use different metrics to create the new dashboards. So this is all about the health monitoring page and how you can use this health monitoring while troubleshooting, how you can add new dashboards. Let's quickly generate some traffic and see how it works and how the target failover works, right? Let's SSH into one of the application servers that I have in the network that is behind the firewall cluster. I just wanted to show you that traffic from this application servers are going through the firewalls. So here, if you notice, the policy that is attached to the firewall has a allow all rule, which is basically like allowing all the traffic. So by the way, it is not a recommended rule. I just configured this rule just for the demo purpose. So I'm not recommending you to create an allow all rule in your network. So let's initiate a traffic from the application server to internet. I'm doing a simple test here, nothing fancy, to show that the traffic is going through the firewall. So let's ping 8888 from the server and and let's see if it works. See, the ping is working, right? Because we have the allow rule. Let's go to the FMC and edit the access control policy and add a rule to block the ICMP traffic and save and deploy. Let's again initiate a ping from the server. Now it should fail because we have a block rule on the firewall. Okay, as expected, ping is not going through, which means our rule is working. It is the traffic is going through the firewall, right? Let's see the logs on the FMC Unified Event Viewer. So you can see the logs either based on the fixed time range here or using a sliding time range like last 15 minutes logs or 10 minutes logs or 30 minutes logs, 1 hour, etc. Or you can go live and see the logs in real time, right? So here, if you see these are the logs. So the traffic was allowed when we have an allowal rule, and it was blocked when we added a new rule to block the ICMP traffic. Right here, you can also filter the logs based on several parameters like source IP or destination IP port, etc., etc. Right? You can filter these logs based on the parameters. And also, if you remember, we discussed about target failover in our previous videos. We saw how to enable that on the AWS. Let's now see that in action, how the target failover works, right? So we already logged into one of the application servers here. So let's SSH into the second application server. Both these VMs are behind my cluster of firewalls. So all the traffic from these application servers are going through the firewalls via the gateway load balancer in AWS. Here I also logged in into all the three FTDs. So on all the three FTDs that we have in the cluster, I'm starting a packet capture. See, so the packet capture is running on all the three FTDs. And let's initiate a connection from application 1 server to application 2 server. Okay, we initiated a connection. Let's see which firewall node is handling this connection. So as you can see, FTD2 is handling this specific connection. So let's shut down that FTD. And if the target failover feature is working as expected, the connection should be handled by another node in the cluster without dropping the traffic. Okay, let's take a look at other two FTDs and see whether one of them is now handling this traffic or not. Okay, so if you see, FTD3 is now becoming a control node because FTD2 was a control node and we shut down that control node. So one of the data nodes, that is FTD3, is now becoming a control node. If you see, it is showing that one, data node to control node. And if you see, FTD1 is now handling the traffic flow, this specific traffic flow, which means target failover feature is working as expected. That brings us to the end of this video. In this session, we explored the complete operational view of our FTDv cluster in AWS. We walked through the AWS environment to review all the resources deployed by two CloudFormation stacks, and including the firewalls, autoscaling group, target groups, CloudWatch logs, gateway load balancer setup, etc., etc. Then we switched to the FMC console to see how the cluster firewalls appear once onboarded. We discussed the roles of the control and data nodes and the cluster control link, and looked at the live status and health monitoring dashboards. Finally, we also walked through a target failover demo to see how the cluster dynamically maintains the availability during the node failure. Um, so so yeah, these are all the things that we covered in this video. And also that wrapped up our three-part video series on Cisco FTDv clustering with Autoscale in AWS. So if you just to summarize, in part one, we started with concepts and architecture, understanding how clustering and autoscale work together and their use cases and traffic flow designs, etc. And in part two, we moved into the hands-on deployment where we built the entire solution step by step on AWS using the CloudFormation templates. And in this final part, we explored the operational aspects, understanding how the cluster behaves in real time, how the failover and scaling events occur, and how to monitor and validate the deployment. I hope this series helped you get a complete understanding from design to deployment to operations of how Cisco FTDv integrates with AWS services for scalable and resilient security. This is all I have. Thank you so much for watching. See you soon with another video on a new topic. Thank you.